Hi, my name is Nirmal Lal. I'm going to talk about my final project on MapReduce applications for analytics on computer usage log. Shifting to the first slide, that's the introduction. Um, what is analytics on computer log usage? It really historically relates to collecting and reporting on users' data on machines. It relates to OS resource usage regarding CPU, memory, network traffic, and many sorts around the kernel. Um, Disk space usage. Um, Many of the analytics that we have seen so far relates to traditional time series data on such OS collection. We store them, we try to create reports. There are products out there that do a pretty decent job of collecting and reporting on um, machines individually. What we don't see is massive collection of data, consolidation, or predictive analytics that we see out there for um, Apache weblog analysis and sorts. So big data with all the changes around is making it happen where we're able to see how to collect data in a more scalable manner, spread the data out, and do massive processing on it using the MapReduce paradigm as the core of it. So far, there has been a lot more exploration on the web logs and clickstream analysis that we see out there on Apache logs. One of our assignments dealt with that. Um, there is some discussion starting around doing analytics on machine data, but in my initial research, I found that it's still not quite there. There are different initiatives around it. I've seen Amazon trying to use Ganglia for some similar reporting, um, more closely tied to, I would say, the Hadoop cluster monitoring. But like if we have scenarios where we are looking at large scale deployments in a data center cloud where we have hundreds and thousands of machines, collecting such information in a scalable manner and then doing predictive analytics can add value. It helps look at the health of the machines, monitor, predict how they might behave, um, and so forth. So moving on to the next slide, what really is machine data? Just before we actually start looking into what we are going to do with the data, is data gets generated on the machine in many forms. Application processes, HTTP processes, writing system logs, event logs, history, um, human interaction with applications. We create blogs, documents, emails, text messages. Machine data is a third form where it's interaction of various components running on a machine, disk usage, CPU usage, IO usage, um, network traffic. Network traffic is another one which a lot of research papers have found where they have been doing analysis. But again, they have been traditional analysis, um, scaled up to just one machine. Larger the machine, the better, but it would not stop, the scaling would stop at the machine size possible in a given time. We'll focus here on some of the OS resource usage metric around CPU IO and network bandwidth or disk IO very specifically, and we'll create a framework to collect data and help manage some monitoring and health around the machines. Um, so establishing the project goal, we want to set up a scalable data collection. We want to have the system monitor all the metrics on the kernel, collect it. Once we have collected the data based on whatever we decide, some agents on each of the machines, we would want it to be saved off in a large repository, a scalable repository. Once we have saved it up, at that point we would want to do some analysis on that. Simple analysis could be aggregation, charting on trends, which has been there most of the time. Just that that's a good use case to start off with, but it that's where we don't need to stop. That's the basis. It's like a baseline that we establish in terms of producing reports that are out there today. However, in this case, we would have better data collection, which could be scalable to thousands of machines, and the amount of data generated could be saved in a better repository in a more distributed fashion than traditional data stores or databases have provided so far. So that's the project goal, is to establish the collection, movement and storing of data, and then doing some basic analytics on that and setting up a framework such that we can continue on doing more research on what other predictive analytics can be done on that. Okay. So here's a big picture. What we see here up machines, these machine 1, machine 2, machine n are the real machines that are to be monitored. What I've picked up is CollectL. It's an open source utility to collect OS metrics, all of the CPU, I/O related metrics. It's got good amount of collection, and the plus side is it's very lightweight. It does not take too much OS resources. It has a pluggable uh, framework where I could have customized collectors added on to have more data points. So collector utility can be run in two modes, two basic modes. One is to collect file information on all the OS metrics and dump it into a local file. The second is it can send information across a TCP port. So what another point that I had been looking at is, how do you send data not bottlenecking through one socket or one host that typically we see? Typical ETLs that push data from operational data store into warehouse, even if they run on all the operational data stores, when they send data, like it's like one point of concentration, the warehouse where it's reaching, it's just one machine in a traditional sense. Um, so the next stage was like, okay, I want to send data to a more spread out repository. HDFS is right there, which is going to be able to help do that job for us. Good thing is that if I talk to HDFS from all the other machines where I'm collecting data, they're not going, like in the sense, they're not all of them traffic being rerouted directly to name node. Name node instructs, and then actual RPC calls or network traffic flows from that machine where data is being collected to the data node. So there, the movement of data is sort of optimized. But the next challenge I had was, how do you move that data from? So exploring multiple options, Flume NG came up very high in the list. Having set up Flume was very easy. So what Flume does is that once you initiate the agent, it will collect the data, listen on a TCP port that collector can send to, and then at the sync side of it, it can write to HDFS target. So that was an easy setup. So having set up that, I had a mechanism to run collection and ship the data to the HDFS nodes. Doing so directly in HDFS rather than using other databases, could be Mongo, Cassandra, it could be HBase, but I decided to continue using HDFS because I was looking at Pig and Hive as a way to map my analytics on top of, or ad hoc query, I would say, on top of the sort of raw data. And keeping the data in that raw form, in Hive, I was able to use external tables to do that. While the data was in the raw form, it gives us more openness to see if I could run some other analytics. in mind came RMR, like R Hadoop, or even looking at Mahout algorithms to see if I can get some more meaningful answers from the data points that we collect. Um, Moving to the next slide. So once the data was collected, this is the HDFS data. How do we do some of the basic analytics and reporting? So um, as I mentioned earlier, Hive external table is what I mapped the data onto. Mapped it onto the data. Then once I had the Hive tables, I could even start doing some pig based analytics, but I stuck to Hive given the timelines in the project. Um, and I ran a couple of queries, which I'll show you in the next slide. So that was the basic ad hoc uh, querying of the data. And here, analytics report, I've like just made a kind of a blob here, but it really expands into a HTTP server running where I have some HTML and JavaScript D3 visualization that I'm using to look at the output of the Hive data and do some charting. So that gives me the baseline of what we have today in terms of the reporting that people see. But at the back end, it's vastly scaled, largely scalable that I have, right? So moving on to the next slide is now how do I test it? In my experiment, what I did is created an Amazon EMR instance, picked up MapR M5 distribution for running a Hive example. And all of this setup that I did was based on a script, setup.ksh, that I created, which is a bootstrap script that I wrote to set up all of the components, installing collector, Flume, starting the agents, um, and creating the HDFS file, creating Hive external tables. So just a snapshot of where I had been providing the bootstrap during the cluster creation, the EMR cluster that I created. Um, and here is some raw data that I collected. So when Flume sends the data, the collector data is the folder in HDFS where I'm collecting the data, and Flume is prepending data as flume.data with some timestamp. So files are getting created as you see here, and then I'm looking at, as one example file I looked at it, it has all the data that I needed. It has the host name, followed by the timestamp, and then all the metrics around the CPU. And here's the kind of a command line output of collector directly showing you with the header information what are the kind of information for CPU, disk, and network we are collecting. So, and here's a Hive table, the external table that I mapped to exactly that collector data that I'm collecting. Um, and here's a query that I ran. I did a select for a given time period for averaging the CPU usage or the write usage with a group by to get the data, just an example data. Um, Based on that example data, I was able to do the visualization using the D3. Here I have for a group of hosts. So for a given host, I'm just charting the three data points on CPU, disk, and network packet usage. And so there's a visualization. But this is just an example. There are many more complicated graphs we could build. Moving on to my conclusion. So what it gives me is a very scalable Flume-based data collection with a collector at one and HDFS at the other end. And now that I have data in HDFS, I could start exploring and thinking of better ways of analyzing the data. I have built a framework on visualization with a embedded HTTP server which has D3 installed in it. And so that's where we are today. What's next? Next is to take a look at some of the pattern classification, machine learning related algorithms that Mahout may offer. Um, I could look at these data points as an n vector of and collecting it for a period of time and for all the hosts, and start looking at it in more detail as we go along. With the current project timeline and the number of machines available at my disposal, there was not enough data that I could collect where I was able to run some of these machine learning tools against it. But that's the follow-up that's going to happen. Thank you very much. That concludes my presentation.